Okay, sorry, we did forgot to record the session.
No, I take notes, but it's better to listen again.
So let me share my screen, okay?
Yeah.
Share.
I need to stop, right? Yeah.
No, I just stop it. So range finder, just to put down some examples that I know because I usually use them a lot. These kind of sensors is time of flight or rangefinder. They are called like this. For example, this is a really small laser rangefinder, and the laser rangefinders are defined usually between 0 to 30 centimeters, between 24 to 1 meter, and usually from half meter to 7 meters. Why?
Yeah.
Because the ones that have shorter range are between 0 to 24. What they have is a laser and a diode to detect the reflection. And the distance between both is what gives you the range. So for example, this one has shorter range, but it's really, really accurate and actually works really well. And it's a straightforward line that doesn't have any problem with.
But it's expensive. I mean, look at the price. I mean,
Okay. I'm giving you an overview of the sensor.
It's 3 and it's 4 something, and now it's
you have these ones that we have in the lab also. Let me see. Actually, this is the sharp. This is a really common sensor. This is a short range. So actually, this usually works between more or less 4 centimeters to 30. And this is still quite small, and it still uses the PHT connector that you were using with the battery. Okay. These sensors are really accurate, and if you look online on the data sheet, I'm going to draw the beam of reflection. Usually is quite straight, opens up usually around 30 degrees.
Okay.
So it's difficult to have fake readings with these ones. In case you want to go to ultrasonic, that is something that in toy devices they use a lot to like make the face or make the different ultrasonic or oh my god, ultrasonic. I recommend it to use the Max Sonar. Here,
yeah, last time I take a look at it too, but again, it's like 25 something. So I was like,
Yeah, I know they are more expensive, but those ones are really accurate. And actually, these ones you can find them for like really broad field. Okay. As far as I know, as I check most of the data sheet is only up to 3 meters, but around 70 degrees of beam, more or less. To longer one, it means with a reach of 9 meters, that in this case you obviously don't need, and a beam of 20. So in your case, I will go for the laser one, or you can actually produce your own. Like Neil has an example. It's called asynchronous cruise light detection. So you can use it for measuring. So what you do is have a phototransistor, because this sensor works in this way. You have a LED. You can look for a powerful LED. Yeah. Maybe infrared. And you produce a little case to make the directionality of the LED come more straight. And you can embed a photodiode, a phototransistor to detect the reflection of the object.
I think I have an IR receiver. Can I use it? Like
in that case, you will need to look. Yeah, if you have an IR receiver, IR, those ones are IR diodes. I will look for IR phototransistor that we have in the inventory. I will recommend you to look for an LED that is infrared too. So actually you don't see the light, or you can actually see the light. If you use an LED that has a broader spectrum of the light and goes above infrared, you should be able also to detect it. Actually, it's below infrared, sorry. That's why it's infra. So Neil has an example of this. And I recommend you to look at the code, because even if the hardware is not really complicated, the most difficult part to embed is the software and how to avoid fake readings and fake detections. Input devices is synchronous light detection.
Yeah.
So as you see, this is, in this case, it's doing with a completely normal red LED. So you are actually seeing the light coming up, but you can replace this with infrareds. And this is how basically LiDARs and time of flight sensor works with, because they actually have a emitter and a receiver. This is, let's say, the same as a ultrasonic, but in really, really small packets. Instead of working with sound, working with light. The concept of how they work is actually this one.
Yeah.
And the code, we know that you will understand the code of this one is quite good. It does in a really, really clean way. Okay, let's see. What else?
Now for the.
In my opinion, the easiest one to implement is the one that I showed you, the SparkFun onboard laser rangefinder and the Max Sonar.
Okay.
They are really accurate by defect, like out of the box. And you don't need to debug too much. But we know they have a price, but you could embed this in your PCB using inventory components.
Okay. Okay. Yeah.
Choosing the right transistor and step-up level shifting circuit for the project. Have you all found that this yet?
Yeah. I saw many examples. I get lost. I mean.
Why you want to use a transistor or a MOSFET for what part of the?
Like, because currently the way I designed it, my board is, I want to keep everything at the a motherboard, the ESP board, like 3.3. And then if I want to switch on something, I will use another like motor board, which I want to like it to get receive the 5 volt.
Sorry, I didn't understood that part.
How can I explain it? Well, actually, I just want to use my ESP33 to work with 5 volt motors, for example. So
yeah, you need to use a step-up converter.
Yeah, yeah.
In that case, how you dimension the step-up converter will be basically based on your higher punctual consumption, on your peak consumption.
To have a look, maybe you can go into there, Edu, SparkFun boost converter.
Okay.
Well, this is bidirectional.
Oscar,
the idea is that, yeah.
I don't know, like how confident you feel with all this electronic design, because we are already getting a really complex design. But if you want to simplify a lot and not have a step-up reducer, level converter, box converter, what you can use is the LiPo connected in series, and with that you actually will reach 7.4 volts and just reduce everything. That would be an option. If you want to have just one LiPo cell, you will need to use this buck converter. Sorry, Oscar, I didn't want to cut it too much.
No, it's fine.
I am not confident with myself, so give me something simple.
No, if you look for LiPo boost converter, there's I mean, that's one option if you want to design your circuit. Again, this is expensive. This is the skinny one. Yeah. So that takes out the battery from your the voltage from your battery, and then brings it to 5 volt output and regulate it. So that's like how you would normally do it. If you otherwise want to just step it up, you can either look at this chip and try to find it. But for example, there's no like way of doing it just with like a normal transistor or just a voltage divider or something like that. You need to put something like that makes the conversion. There's something much smaller if you look for NCP, Spark Fun, step up, 5 volts. NCP 1402. That's for example a step up board that converts up to 5, but I think it's retired, but we can probably find the replacement that they put.
The
idea is that you have.
The problem is this, Oscar.
Yeah.
The outputting power, usually the stepping up is not that high in general.
How? Because your servos will run at 5.
5 or maximum 6, yeah.
Okay. And can they run at what's the minimum level that they can work at? Do you know?
I think I tried to run at like 3.3 and it's a bit slow, but it starts more rotating. I think for 5
they work, but they lose torque, a lot of torque.
Yeah. So the minimum in the datasheet is 4.8, I think.
To have them reliably working, yes. Especially if you want to like use them as motor wheels.
So 5 is good.
I don't know. I will consider to actually connect 2 LiPo cells in series to have a battery of 7.4 volts and reduce everything.
Okay.
One line to 5 volts and another line to 3 volts.
Okay.
That will simplify a lot your life. The difference is you will need to charge them, have a way to disconnect each cell and make them work and charge each one of them individually.
Okay. Maybe it's easier for me to digest. I mean, I understand clearly what you are saying, but before, no.
Because in the inventory, we don't have anything like that, right?
No,
like,
no, we don't.
But will we start having, we should get those things because everything is going to 3.3 now.
Yes. So this is how let's say a 2S battery that is a 4.7 volts is wired. The point of this is you take out the power of these ones, but you need to find a way on how to actually connect them so you can also recharge them.
Yeah.
That is going to be slightly more tricky. Which MOSFET? I think you were talking about MOSFET. Okay, I lost your document. Sorry.
What do you need a MOSFET for? If you're using servos?
I just need to consider options. I mean.
Okay, the MOSFET will depend on your motor.
Yeah.
But he's using most servos, so.
No. But she said that maybe she wants to introduce later on DC motor.
Okay. Well, there are 3 MOSFETs, I think, in the inventory, and one that is super big that you won't have any problem.
Yes. If you introduce this one, like it will run on everything.
Okay.
Yeah, but I mean, even the other one, the first one,
even this
0.7
one,
amps, I don't think.
That is ultra small, is really small. Will still work the same well if you don't run it for a long time with a big motor. Actually, this component has exactly the same shape as this one, the black one that is inside.
It's like the voltage regulator, the 3-pin.
Yeah.
Can you go back to the inventory? Because
yes.
We don't have that very many of those.
Just with that kind of MOSFET, do you need to worry about the heat? Or
Sorry?
Depends on on the percentage of the amperes that is capable you're running.
Okay.
With MOSFETs, I just state that you use half of the continuous amperes. Sorry, Antonio, I'm gonna mute. You have a lot of back sound. For example, this MOSFET is 16 amps. If you use peak consumption of 16, it's no big deal, like for 2-3 seconds. But if you use 8 amperes continuous, they usually dissipate well enough the heat. If you use around 70%, you might need to have assisted cooling or a big dissipation plate. Let's say the ground pad connected to a big part of the PCB. Actually, the PCB dissipation, if you do it properly, works really well.
Thank you.
For example, this one, let's go a little bit. Data sheet. Okay, thank you. How to, okay. Okay, let's see. They usually state a mounting diagram on how you should connect let's say the PCB heatsink. Oh my god, it doesn't state. This one. This is also a really common MOSFET. This one is usually the one that people use in Arduino. NC channel 16 DU2. We just downloaded. Here the state more or less the power dissipation in one of these, the heat dissipation, and the rate depends on the amperage that you are using continuously. Normalized get hot voltage temperature. Also, like if the MOSFET gets really hot, sometimes you can get fake activation because you need more voltage to actually activate it. So actually, I always use MOSFETs at half of the current. With that, you don't have any heat problem dissipation, most of them. Mechanical data. So usually the big ground plate is metallic and it's in all the back. So usually use a little bit of thermal paste or you solder directly to the PCB, to one part of the PCB that is not connected to anything, not even to ground. And that's it. Depends on the MOSFET that you're using. They state a drawing like this with the size of the dissipation plate. In this case, they don't, but sometimes they state the recommended size. And more questions of Tue.
Thanks.
Why did you mill the copper on the antenna of the ESP? This is something that we will cover actually on networking. But to give you an idea, ground, let's say the antenna works in a kind of similar way of an analog input.
Yeah.
So what it does, it catches the radio frequency in the air and transforms it to a signal. And that is done by the design of the PCB antenna layout or the physical wire antenna. So the problem is if you have ground and you wrap around the antenna, that is making like a Faraday cage on the antenna. You know what is a Faraday cage?
No.
Okay, a Faraday cage is an isolation. Faraday cage is an isolation of electromagnetic radio frequencies for electronics. So actually, for example, you can have a really high electrical discharge, but if you are in a metallic cell, this will absorb everything and the electricity will not penetrate inside.
Okay. Okay. Yeah.
So this happens the same. Let's say in this case, the man is the antenna and ground is the grid around it. And that actually, in this case, the grid is grounded because it's connected to the floor. So what will happen is the antenna will not receive the radio frequencies, the radiomagnetic frequencies, and by so it will not be able to transmit or receive any signal.
Okay.
And actually, microwaves, they are Faraday cages. That's why the glass on the door is like has this kind of holy metallic mesh. So the radios, the microwave don't get out. So why we mill it? Because ideally, the antenna, any antenna on a PCB layout, ESP, for example, not MCU, it really doesn't matter. Like if you look for any design of antenna on any PCB design circuit, the antenna should be out. Okay, should be out without ground. So it is as least isolated as possible. Let's say in the air.
Yeah.
What happened with Arduino is I'm sorry, but I'm not that good at wiring and making the layout of the board. So I was not able to take the antenna out while keeping all the connectors. So what the solution we had was to actually Arduino try to reduce the isolation of the board as much as possible by milling all the copper that is behind it. So the copper that is behind it doesn't reduce the range. Actually, having the pieces of copper around this area and having some traces reduces the range. So this ESP is not getting the best range as possible, but is what I could do, and I could find another solution. Actually, Oscar is redesigning a little bit, so he find out a better solution.
So sure, there should be no traces under the antenna, right?
There should not be traces under the antenna at all. Especially, you always want to avoid, especially power lines. Data lines, you can deal with it, but power lines, no. If it's ground, for example, I think one of these ones is ground, yes, because this one is ground, it's still not the best, but the worst you can get is actually have a power plus VCC next to the antenna. That is the worst that you can have, because that produces a lot of noise. So this, let's say, is the best we could do.
Okay.
And that's why we mill the copper under it. So we try to don't reduce the range as much as possible. To try not to reduce the range? Yes, not as much as possible. More questions?
3D model of the board in KiCad to Fusion 360. I've never done that, but if you 3D KiCad to STL IGES. So what I would, I've never done that, but I will try to look for ways of exporting either to STL or IGS and then import that into Fusion. Normally STL are, I mean, Fusion will handle them, but you will lose like surface
well, the thing
information.
is, in KiCad, I cannot export to anything. I mean,
you cannot export to anything. Okay.
Yeah.
Well, there must be a way. But I don't know. I've never done it. We can look into it and then try to come back.
Extension, a FreeCAD. But it's FreeCAD.
No, but I mean, if you can, I mean, at the end, if you can export for whatever program or any,
okay.
What we were looking for is to export to a generic format like STL or IGS or.
In this case, Oscar, you will want to export to a step file.
Step.
Yeah,
okay.
I mean, whatever. But yeah. What other question? Routing the board in PC new. Sorry, I started going up.
Yeah. So actually, that's for example, if it's like I cannot solve it by rotating the components, and if the voltage drop is not important, I use diodes. Then I can go.
What do you mean? I don't understand this part. Sorry.
So yes, you can use diodes, but be careful with if the currents have to come back or anything. So if you don't, if you're not sure about a line, for example, if it's not a power line or something like that, I will put a 0 ohm resistor.
Okay, so basically, what you want to say is what happened when you have this situation?
Like
that you want to continue in here?
How can I explain? Maybe in my
This?
screen, I think.
Okay.
Like for this one, I have 2 lines, and I need to go this one, go up. Did you see my screen or not?
No.
Sorry, give me a second. So for example, this one I need to go up, and this one I need to go down, but it's impossible now. So the trick is I try to use the diodes here, so I can go here and then go up.
Okay, you don't use diodes to work. What you are doing is a jumper, basically. So
Yeah,
what you do is you use a 0K resistor. It's a resistor that has no resistance.
Okay.
We have a lot of those.
Yeah, I will put the link in the inventory.
The only thing here is in KiCad, you should add it into the schematic as well and then reload the netlist. And one other comment here, if it makes your life easier, all the grounds in the ESP32 are internally connected. So you don't have to connect them all between themselves. So the internal lines, so under the ESP32, if it helps you for the routing, if you just connect one, it's fine. You don't have to.
Yeah.
It's really recommended, no, Oscar?
It depends. I mean, I had the same question, and they said like for heat dissipation, if you want to connect the pad, it's fine. But the other ones, if you don't connect it, some people even say that it might be helpful for the antenna. So for the interferences in the antenna or something like that. So they say that is not mandatory.
Okay. Yeah.
But I mean,
you know better. Like it really depends on.
No, I don't know better because no one knows better. But it's in. I was reading in these specific forums that it's and they say that. So yes, but if you already solved the design, that's fine. Just leave it like that.
Yeah. Okay. Yeah. Well, that's it. Thanks a lot. Thanks to solve now.
No, thank you, because it's nice that you were working on this and that you have like all these questions, and it means that you are getting stuff done. So thank you.
Okay, thanks. Anyone else can? Yeah.
Next. Hello.
I have a couple of questions, but not organized as she was. So
are they like somehow structured? At least like are they oriented towards a specific problem or are very generic?
Not generic, no. One like a bit generic actually. Like the first one is the ESC, the electronic speed controller. I kind of trying to understand it, and I want to use the brushless DC motor for positioning, and kind of understand that it's kind of using a PWM to control between two range, but I don't understand how I can use this to position the DC motor.
Arman, first question, why do you want to use a brushless for positioning?
I thought first I just want to have a diversity in my project
Okay.
to try different things, but also I thought maybe it's faster than the step motor.
No. It's
No?
okay. And the problem with when you use a brushless for positioning is they don't have too much torque. They are good in speed, but not in torque. So actually, unless you want to move something really, 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 really light, it's not going to behave properly. Let's say, for example, the torque of an EMA 17. If you want to equivalent to the torque of a brushless motor, an EMA 17 is 15 euros. A brushless motor of the same torque is around 150 to 250 euros. And the size of the brushless will be more or less this size. And this thick. So they are not ideal for this kind of things. Second, on the step positioning of brushless motor, you have two things. One is the hardware on how you move, on how you control the pulses. And after is actually how you are getting the position. Because it does not the same as a stepper, that you can do it by hardware activating. In a brushless, as you have everything connected in just one circuit, because they have common ground of the 3 poles, what you need to do is activate each one of them at really high speed. But you need to get some kind of feedback to actually know at what speed you need to compensate each coil against each coil. And that is called back EMF. That is back electromagnetic frequency interference, I think, or something.
Field.
Yes, no?
Field.
Back electromagnetic
electromagnetic field.
So it's kind of getting an analog signal from the output that you are receiving. It's quite complex in the way how it's interacted, and actually I have been looking for this in this field a lot of time, and there is not that many projects, neither software, that does this. Actually, it's really tricky. It's really tricky on how you implement it, how you control the brushless, and how to read back EMF properly. And actually, since more or less 1-2 years, some manufacturers have embedded brushless speed controllers, microcontrollers, with that has EMF sensing. And this is something that before was not that common. Recommended, if you are interested in this, I will not discourage you, but I don't think it's the best option for your final project. It will take you just the whole academy to do this properly, just the brushless control. But if you're interested in this, there is a project called OpenBSC that has some guys designed it in a small community for speed controllers of brushes that they enable EMF and brushless control in an open source way, and the PCB layout is really nice.
Yeah, I have the project actually. Like I saw the project. I just go through the documentations, and like it's well documented, but I don't understand most of it, so I just trying to understand it.
Is, let's say, how you control a brushless with back EMF is really high level hardware and programming at the same time, and knowing a lot about interference and electromagnetic fields. Like for me, it's quite hard, but I'm not an electronic engineer or anything.
Me neither.
But I know it's quite complex.
And I have a really dumb question.
Yes.
I dismount the stepper motor of my TV driver, but how you connecting this is like it's super small pin. I couldn't find anything to go through this.
Can you zoom in?
Like
It's actually really thin. In my case,
It's super small. Like I couldn't find anything to like connect it.
I just solder directly the wires to the pin connector.
Like I actually did it for the fan. The fan was quite big. It's like this. And it's a brushless and it has a controller on it. And I want to also use this for positioning, but I realize I can't. I just can control the speed.
Yeah, those browsers are ultra simplified. Like let's say what you want to do is like have control of the RPM, and usually you do by changing the voltage, like enable a PWM, and by so usually the computers either they have an encoder that usually they don't, but they have a comparator of PWM to revolution.
And the last question is that in a triplexing, I didn't understand triplexing. I didn't understand why we are not connecting the circuit to the common ground. Like it's like the circuit was a bit weird. I don't know why.
Well, the idea of the Charlie plexing is, I don't have the circuit exactly in my head, but the idea is that you're combining N pins, 2, 3, to turn on different LEDs, so that by the combination of them, they will act either as power or as ground, respectively.
I watched
so depending on
video,
how,
which I just put a video in the chat, which I watched, and it really helped me understanding it.
There you go.
But yeah, basically the pins are the ground.
Why to answer that really shortly. In the Charlie plexing, you don't have connection to power, neither to ground. Let's say what you use the pins as output or as sink. When the pin is in sync, it works as ground. When the pin is in high, it's working as a voltage plus. So by alternating how the pins work, you are not emulating, but making the circuit work as a normal VCC and ground voltage. In this case, you are constrained to the milliamperes of maximum delivery of the pin microcontroller, because if this one is ground and this one is plus, it's not giving the full voltage of the circuit, the full amperes of the circuit. The constraint is the milliamperes that the pin can handle. That, for example, in an 8010E1 is 20 milliamps.
So then if I want to use it, for example, for bigger LED, I should have used the MOSFETs to like, but also it's not working because it's just going one direction, it's not going the other direction.
When you start adding this kind of components, it's more complex. But... More questions? Or
I'm done, thank you.
I have a couple so now it's time to dump questions. One is I have a problem with the programmer because.
Which one?
Yeah. What?
FTDI, no?
FTDI. So the FTDI, the thing is that I miss something, so I know that I should program this to be programmed, to be a programmer, or just like that?
No, the FTDI, you don't have to do anything. It already comes off the shelf as a.
Okay.
Actually, it's not a programmer. It just converts USB to serial.
To serial. Okay.
To RxTX.
Okay. The other thing is that I do have the FTDI cable that you gave us the last day, and the ESP that I soldered. And the thing is that when I plug it, and I want to upload something, I have just to put the cable in somewhere position, and if it's not exactly there, I miss the connection, so I can't upload the programs. So I don't know how to debug this cable. So that's why I was trying to make this work, but it doesn't seem also to work. But I do actually get sometimes some programs to upload. But for example, now I'm trying to receive something by serial communication, and I don't receive a thing. So that's one of the things I do have. Right.
Do you have any soldering equipment at hand?
Yeah, I do, and I fix it, and I try it with the multimeter, so to check it, and it seems to work.
So, well, two things, and well, you suffered this at the when with the FTDIs, is that the ones that we make are very sensitive to, like, if there's bad soldering or something that is not fully connected, even if your computer detects it, it detects it through a pin, but that doesn't mean that it's actually correct, the whole soldering to transmit information. So a good tip is to try to resolder the whole thing, just heat up everything, leave it for a little while until there's, don't put more solder on anything, just let the solder flow. And try that, try to debug it in a very methodic way so that you are able to identify where the problem is. If it's the cable, if it's the FTDI chip, or if it's the ESP chip, and then you start trying combinations of them and trying to think, okay, I resolder everything and I try the cable with the ESP32.
Okay,
it works. But if I move it this way, then it doesn't work. Okay, then let's try with the other chip. Does it happen the same or doesn't work at all?
Okay.
And try to eliminate little by little. It's very difficult to debug like that without more equipment, but at least try to go for it in a way. For what it sounds, it's either a bad soldering on the ESP or a problem with the cable and both cable and FTDI, but I think is not very likely because the cables normally have worked quite well. So probably just a bad soldering matter. But again, it's very difficult to tell, so just try to test it.
Thanks.
No problem.
Vamos a intentarlo.
Any other things?
Hello.
Either
someone?
I have some questions. Some weird thing is not related to my final project, but it's electronics. Like the HRSC04, I think is a digital sensor. But when I try to check like analog rate in the Arduino, it's returned some values. So what is that value?
Sorry, what sensor?
The ultrasonic
the
sensor.
ultrasonic one, the generic one.
Yeah.
Ah.
I read that it is a digital sensor, but when I try analog read it, it returns something. What is that something? What is that value?
It's the time in milliseconds it takes, or in microseconds it takes to leave
No,
and
I
come back.
didn't use the pulse in. I just read it. I just read the signals. I just read whatever it is and what is that. I think it's, I don't understand that thing.
I mean, at the end, that if for any sensor, if you read the digital pins, they're gonna be oscillating in whatever voltage value, and that can be just a signal that I don't know. It's like to assimilate it somehow, it could be like a PWM type of thing. So the voltage state could be, who knows. The only thing that by reading that pin, you are putting the input pins. If I say it right, in a high impedance state, so means that you have a very high resistance, and then you are very likely fucking up the signal itself. So what you're reading is nothing. I mean, it doesn't even mean that it's the data line. You are not. It's just the state of the pin, but you are making a different circuit.
Okay.
By the way, I know I have to know how to try to upload an HTML to my ESP32 for my final project, but since I have this kind of little problems, I go step by step. But I'm looking for it. No, I'm not connected.
This electronics is too much for me.
Something that you might want to try in case you cannot solve the problem with the ESP is not that reliable, but is ESP over OTA, that is over-the-air programming. So you upload a sketch the first time with the FTDI connector to the ESP, and after you can upload the sketches just with the Wi-Fi connection. I know this possibility exists. I don't know how it will work when you try to upload other more complex sketches, but I know it's possible. I never tried it.
It is possible. I would recommend it only when you are like super confident on what you have. It is a little bit tricky, but that is, for example, imagine just that, like a case study is, imagine that you have IoT devices remotely that are connected to the internet, and you want to upgrade their firmware remotely. So you will be able to download the firmware into the ESP, and then the ESP flashes itself. And as you can imagine, that's a little bit like tricky to not fuck up. Probably is super robust or something, but I mean, if you have the cable, at the beginning, even you have to like program it so that it's able to understand that you're programming it over OTA. So at least one time you have to program it by cable to enable the whole thing.
More? Someone? Guys? Hello? Someone else?
Okay, so then.
So
maybe we can call this session done, right?
Yes, let's have a break.
I know Antoine had a problem yesterday, but he's not here anymore.
Sorry, Benjamin?
I know Antoine was asking something yesterday about he had a problem with his Arduino. He's back, but I don't know if he solved it. Antoine? Ah, he's gone. But yeah, whatever.
Okay, let's take a break. I'm gonna stop the recording.